Greetings. Today, it's day 3. We're continuing with our topic from under electricity and magnetism. And today we're going to be our topic, our concept area. It's based on conservation of charge. Conservation of charge. Yeah, it's under electricity and magnetism. The content or the concept area is electrostatics, conservation of charge. As I've explained in the last lesson, that the charges, they cannot be destroyed or be created, but they're gonna be conserved onto materials. As I've said, the charges, when you wrap the object, both of them, because the conservation means the charges are being conserved, they're not destroyed or created. So this simply means if one object is being in contact with another object, it's either one of the object is gonna gain or lose electrons, as I've explained and as I've done some PhET simulations. That's where you saw the Jay-Z losing electrons, and it tend to become positively charged. So the balloon usually what happened, it gained electrons, so it became negatively charged. Because another thing that we're going to do now, okay, we're gonna carry on, but since it's our video here, we will be focusing mostly on the conclusion. That's where we'll have to summarize and recap and revise what we have done. So on our consolidation or our conclusion, I'm just gonna play a video, but I'm be explaining everything there on the video. I've just created a video, so I'm going to be playing everything just to summarize what we have learned about. But the lesson will continue with the lesson. It will be involving. I'm just gonna show the development plan of this lesson, the lesson 3. Just to highlight some few points, then the main focus will be on the conclusion, and we'll also do some calculations. As I've said, that we've also included the worksheet. So again here, what I got was the video, which is also involved in the blended learning, where learners have been introduced, or the video is going to be playing that summarizing all what you have learned. So I'm just gonna go through our lesson today, and then we're going to play the video, but I'll be also explaining everything that is happening there, and then we'll also answer some few questions. So now I'm gonna go on my lesson plan for today. Okay, so now we're going to be talking about electricity and magnetism, and the concept is electrostatic under conservation of charge. Okay, the CAPS document page is 41 to the lesson duration is 1 hour. So I'm just gonna go through the definition of the principle of conservation of charge. Okay, the principle of charge, as I've said, states that the net charge of an isolated system remains constant during any physical process, e.g. two charged objects making contact and separating. As I've said, that two charges, even if, as I've said, the balloon, there will be no lost or gain electrons out of the system, meaning if these two systems, if they have two positively charged and negatively charged, like neutral, it's either one of it is gonna gain electrons. As I've said, on the triboelectric effect, it's gonna gain more electrons. It tends to gain more electrons or loses electrons, as we said on the previous lesson. So now on my development, we're going to explain the units of charge, which are here. But our main focus here, this is the formula, the quantization, the charge quantization. Here's the formula. The Q stands for the charge, and N stands for the constant, and QE stands for the charge. Okay, all the electrons or protons, they have this charge, which is measured in nanocoulombs, which is 1 to the times 10 to the power of 9, which is nano. It stands for nanocoulombs, and 1 times 10 to the power -9, and coulombs stand for nanocoulombs. So here's the example that we're going to be doing with the learners. But now the main focus is the consideration of the lesson, or the conclusion of the lesson. As I've said, I'm just going to play this YouTube video, but I'm explaining everything that is happening there. Because due to that, we have to include the blended learning. We'll have to use all of this stuff. So now we'll have to play the video. So I've got the flow. Okay, I've included the worksheet that we're going to be just to explain, and everything that's gonna happen here. Here's the worksheet. Okay, unfortunately, another thing, I couldn't find the best worksheet, but here's the link. We're going to go through it with the learners after we've done. But now the main focus here on my conclusion is that I have to focus on the revision of the previous lessons. So here's I'm going to play this video, but I'll be explaining everything that is happening here. Okay, on my conclusion, that's what I said I'm going to be doing. What's happening here, I've just made a summary. So I've decided to make a summary because now there's no learners, so I'm just going to be explaining everything. The electrostatics, here's the topic: the study of stationary charges. As I've said, the charges are stationary, they move from one object to another. The charge, the property of matter that causes it to experience a force when placed in an electric field, which means the electric field between the charges. Here it is explained now, electric field. Because now, if you remember, if you use a magnet, because we said the topic goes from electricity and magnet. So now we have the electric field, because you can't experience the electricity when there's no field, or because if you remember, electricity, it have to have that field where it experiences the charge. So here it is explained here: a region in space in which an electric charge experiences a force, which I've said here it might be a force of friction force where two objects are rubbed to each other. So now here's the summary. Protons, as I've said, protons, they tend to be positively charged. They do not move. You remember I said that the protons, they don't move, but what moves, it's electrons, which are negatively charged. Here's the friction. The friction causes the transfer of electrons. As I've said, I've been talking about the friction. So here's the example where they are positively charged, which is the proton. Negatively charged, which is the electrons. So in the field here, you see the protons, the arrows, they're showing that the electric field of the protons, they move far away, and the electrons, they move those to the electrons. So here they just made an example what happened as we've done it. So now here's the cloth. I'm just gonna close the volume because I want to explain everything that is happening. So here's the cloth here. They are wrapping the perspex to make it what is happening. The perspex tends to, because it is plastic, it tends to do what? It tends to gain electrons. So now the paper, it tends to lose electrons. So as it does this, he wants this perspex to do what? To gain electrons. So the paper, as we said in the triboelectric effect, it tends to do what? To be positively charged. It wants to gain it wants to be negatively charged. It also wants to lose the electrons. You see, as we have done this here, you see the paper, because of its gaining, it also wants to do what? To gain these electrons which are here. That's why it's jumping to the perspex, because also the paper, it tends to do what? To gain what? Electrons. So now what is happening here? I'm just gonna do here, just to go back to the lesson that I've taught quickly, because I want this triboelectric effect. So you see the paper, the rubber or the balloon, because it's polystyrene. The perspex is usually polystyrene, is made up of plastic. So both of these things, they tend to do what they want to gain electrons every time. So that's what is happening here, because the perspex have gained electrons. Also the paper, that's why it jumps to the perspex. It also wants to gain electrons, because they are both willingly to gain electrons. So now what is going to happen here, the perspex, as you wrap it with the cloth, it's going to become negatively charged, and the cloth, it's going to be positively charged, because you remember when he was wrapping there, that is a friction force. When he was wrapping there, he was gaining electrons from the cloth, because the cloth usually it wants to do what, to lose electrons. So here, this is my summary of the lessons that we've done. Okay, now I've included, as I've said, I've included some questions for the learners here. I've included, here is my worksheet, just a small worksheet which we're going to do on the class due to the time now. I've just included worksheet which state the law of conservation of charge. As I've explained it, the learners will explain it and identify the sphere with an excess of electrons. Here, which sphere which is have the excess of electrons? It's sphere R, because it's negatively charged, which is nanocoulombs. As we've explained at the top there with the development, they're gonna, after we've done the development on our lesson, they're gonna be answering this worksheet and calculate the charge in coulombs, not in nanocoulombs, on each sphere after the separation. So they're going to be used, they're going to use the formula which I've just mentioned here to calculate their charge between these two spheres. Okay, another thing that I've done here, I've just due to I couldn't find the proper, but I've just left the link here, which is got the worksheet which is full of the questions here. So I'm just gonna go through the quickly. I should have just opened this before my video, but I'm going to open it now quickly. So here's my link where you will find the and question chapter, where you will find the questions, which is a worksheet. Here are my questions. So these are all the questions which are based on the conservation of charge, the triboelectric effect, and explaining the electrostatics and the calculations. So here are my textbook exercise, which will just see it here. What are the two charges? Because if they say show the we haven't done them, so the learners will have to do it as their homework. So what are the two types of charges called? It's a proton and an electron, which are it is electron which is negatively charged, which is proton which is positively charged. So they're gonna go through all these questions here as I've explained. Here's my worksheet here. All the questions are here. So the learners will do that. So in conclusion, I've used the blended learning using some videos here and some PhET simulations, and then we've done everything. Thank you, and I hope my lesson was clear to the learners. Thank you.